So a circle A has twice the radius of circle B, okay? So let's say circle B is this much, then circle A has twice the radius, okay? Then you're asked, what is the ratio? This is circle B, this is circle A. You're asked, what is the ratio of this guy's area to this guy's area, okay? So take a few minutes and solve it. Take your time. And once you solve it, you can type over your answer just in the private message over here. So you can type it over to me, or you can type it publicly in the group chat, okay? All right. Well, all right, great. So people are starting to answer the question. So people are starting to answer the question. So great. Yeah, try it. Hi, Queen Lee. Nice to see you again. Very good. Good. Okay. So the ratio of circles, circle A's area to circle B's area. Okay. So remember, the circle A has twice the radius. So this is how we're gonna solve it. Okay. Circle A has twice the radius. Whenever you're given this information, let's say circle B has a radius of 1. Okay. So circle A has a radius of 2, right? Yes, well done, Colin. So circle A has a radius of 1 and circle B has a radius of 2. So what's the area of B gonna be? The area of B is gonna be pi 1 squared, because that's the area of a circle, right? Pi r squared is the area of a circle. So it's gonna be pi 1 squared, right? And now, what's the area of circle A? So the area of circle A, folks, is gonna be pi 2 squared. All right, so that's going to be written as pi times 4, and this is going to be written as pi times 1, right? You can just write this pi to pi times 4. I'm just going to move the 4 over here, right? And so let's think about it a little bit more. But meanwhile, those people who have solved that earlier problem should try to solve this problem, which I'm going to post over here, okay? I'm just going to post this problem here for you. But meanwhile, those who are solving the easier problem, try to get a handle on what the ratio is going to be. So I'm waiting for your answers. The ratio of, yes, well done, Anuj. Well done, Colin. Okay, and this is the harder problem. For those who have already solved this easy problem, try this hard problem, okay? That's a slightly harder problem. So that's a challenge problem for those who want a score above 700. Okay, so this is a 700 plus problem. This is an easier problem. So remember, now it's pi and 4 pi, right? So pi to 4 pi. So you're going to write down pi over, so the circle A's area is 4 pi, and circle B's area is pi. And then pi and pi cancel out. Of course, there's a 1 here. So it's 4 to 1. Okay, or 1 to 4. Remember, the ratio of circle A's area is asked, right? So circle A's is bigger, so it's going to be 4 to 1. All right, let's try one very, very similar problem. Let me get rid of this, and we are going to solve another problem. By the way, this is, yes, these are all calculator problems, but the problems that I'm showing you, you don't even need a calculator. Even though it's going to be on the calculator section, you don't need a calculator to solve these type of problems. Okay, so let's try this one. Right, let's try this problem now. Okay, again, let's see who can solve this harder problem. Meanwhile, we're going to solve this easier problem. One of the very, very standard SAT problems, folks. Very standard SAT problems for rates. Okay, so try this one now. Okay, circle A is now 5 times. Well done, Anuj. Okay, well done. So circle A is 5 times the radius of circle B. Okay, so circle B is over here, and then you can imagine circle A is bigger, right? The radius is 5 times, right? So this radius is 1, and this radius is 5, right? Remember, the radius is given to us. So what's the area of these guys going to be? This is going to be pi 1 squared, and this is going to be pi 5 squared, right? So 5 squared is 25, so you can write this as 25 pi, and this is going to be 1, right? So the ratio of circle A's area to the circle B's area is 25 pi over 1 pi, which is 25 to 1. All right. And now what is this? Okay, this one is a harder problem, but you're right. The people who got it, circle A's area is 9 times that of circle B. So you're basically, the answer is going to be circle B is 1 and circle A's area is 9. So the ratio is going to be 1 to 3. Okay, so that's the answer. I'm not going to solve it. If you want it, email me. I'll respond to you, but this is an important one. So remember, you need to understand this kind of a problem. Okay, now let's try another problem of a very similar type. Okay, so here's the problem. Okay, this is a slightly easier problem. I'm going to post both of these problems side by side so we can solve it together. Remember, solving these problems together with someone who's an expert is really helped a lot of my students, okay? So try to solve it, try to participate. Yes, many of you are posting it in the public. Some people are posting it privately. Very good. Keep at it. That's the way you're going to learn, okay? So try to solve this problem now. Remember, our square's length is tripled, okay? So always take the original length to be 1, okay? So if its original length is 1, then what is the length of the new square? So think about it. Okay, think about that problem. Great, great. People are answering it in the private. Very good. Yes, yes. Okay, so try it. Again, this video is recorded. So if you're having difficulty understanding any of these problems, you can always email me and I'll give you the recording of this video, okay? Well done, Yuri. So that's it. So the ratio is 9 or 9 to 1, right? So, and those people who have solved it, try this harder problem, okay? So try this problem. Meanwhile, we're gonna think about this. A square's length is tripled. So if the length is tripled and it's a square, right? Everything is gonna be tripled, right? So if this is a small square, right? Let's say this side is 1, and because it's a square, all the sides are equal. This is 1, this is 1, this is 1. And if one of the sides is tripled, let's say it became 3 times, right? Like this, right? Everything is tripled here. So it becomes 3, 3, 3, and 3. Now remember, you need to know the area. That area section is going to also come in our geometry section, but these are just areas where I believe you know the area of a square is just the length times width, or it's a square of the length. So it's just going to be 1 times 1, and this is going to be 3 times 3. Okay, so this is 9, and this is 1. Okay, great, great. So this is done here. Now let's think about this problem here. So this is perfect. Now a square's length increases by 5%. Now this problem here, to understand this problem, you need to know percents, which is another topic, but this is how the problems of SAT are based, right? You've got ratios here, and then you've got percents, right? So they're combining both of these ideas in this problem right over here. Okay, so be careful. They will ask you and they will combine both of these ideas. Now there are 10 very important topics, okay? And let me show you the 10 important topics and also the structure of our course real quick. Let me just open this real quick. And then you can understand what the topics are. So the topics are right over here. And I'll also explain to you the structure of our course, and then we are going to solve a few more problems, okay? So here are the 10 most important topics. the high frequency topics. You don't need to study all of these topics here. All you need to know is these particular topics. So there's percents and exponents, and many of you have attended my percents and exponents section, right? There's rates and ratios that we're doing today. Then there's algebra. There are 3 parts of algebra. On Sunday, we did the polynomial and factoring and the quadratics. All right, so every second or third day, we are having lectures here and practice problems as well. And then there's geometry, and then right over here, 2 parts of geometry, and then there's data over here, right? And then of course, there's the word problems. So all of these problems are important, right? And then finally, you attend these lectures. Of course, this is a trial session for some of you, but try to attend these lectures and do the problems, do the practice problems with me, hands-on. That's the best way you'll learn, okay? So let's try this problem now. Okay, so try to focus here. All right, so a square's length is 5% over here, right? So it's 1.05 is the new length, right? So the old length is 1, and the new length is going to be 1.05, right? Remember, the first one is 1 here, and then it's 1.05, right? It's increased by 5%. So the area of this square is just going to be 1 squared, and the area of this guy is going to be 1.05 squared. Okay, so 1.05 squared, it's a calculator problem. So you're going to have 1.05 squared. That's 1.1025, right? So it increased from here to here, right? So that's why this is the answer. So well done, Colin and Anuj as well. Both of you are understanding this. So great, and others are as well privately messaging me. So good job there. All right, so let's move on to the next part, okay? The next part is gonna be over here. So let's say now what will happen in the SAT, they might give you a formula, okay? So let's say the formula is gonna be, let's say the gravitation force, right? Is, let's call it F is equal to M1, which is the mass of one body, mass of another body over, let's say the distance, R squared. This doesn't really matter what's going on here, okay? So let's say the force is given by this, where there are 2 bodies, right? And there's a gravitational force between them, and the R is the distance between them, okay? So now the question is, if the R, the distance between these 2 bodies increases, okay, by 4, okay, then the force between these 2 bodies, what happens to it, okay? Does it increase by 4, or does it, so increase by 4, let's say instead of increase by 4, increases 4 times, okay? That's a better way to say it. So if R increases 4 times, right, then what happens to the new force? Okay, so R increased 4 times. So R became, so let's say the R is 1, now it became 4. Okay, so now what's going to happen to the force? The force is how much, what's the new force? Okay, so that's the question. So let me know, what do you think it is? Let's say, what's the ratio of the new force to the old force? Is it 4, 1/4, 16, or 1/16? These are your choices. Okay, so remember the old force, and always take the R to be equal to 1. So the old force is just going to be M1, M2. You don't really care what these are. Just put R to be equal to 1. Okay, so you get 1 squared, which is M1, M2 over 1, which is M1, M2, right? Right over here. And now you're going to have the new force, which is what happens when the R increased 4 times, right? So what happens to the R? The R becomes, R is equal to 4, right? So new force, guys, is equal to M1, M2 over 4 squared, okay? So that's going to be, yes, take the ratio of the new to the old, right? M1, M2 over 16. So try to think about it. What's going to happen? Is the new, what's going to happen to the new force, right? Because R increases, right, 4 times. So yes, because R increases 4 times, it's going to be M1, M2 over 4 squared, right? So that's going to be M1, M2 over 16, right? So the new force is just the same as the old force, except it's 116 times lower, okay? So it's 116 times lower, okay? So that's your answer, okay? So the answer is 1:16, okay? So well done, people are getting this. All right, so let's move on now. This is, remember, this is an important problem, and email me for the practice sheets where we'll have more problems of this type so you can practice them. And once again, all of these problems are available on the recording, okay? Now, so that was the rates, that was the ratio section, right? There's one piece remaining in the ratio section that's going to be over here, which is the cross section, okay? The cross multiplication, my bad. Okay, so let's try this problem here. This problem should be easy for most of you. Okay, so try this problem here. Okay, very easy problem. So try this one.